low probability value casts doubt on the null hypothesis. How low must the probability value be in order to conclude that the null hypothesis is false? Although there is clearly no right or wrong answer to this question, it is conventional to conclude the null hypothesis is false if the probability value is less than 0.05. More conservative researchers conclude the null hypothesis is false only if the probability value is less than 0.01. When a researcher concludes that the null hypothesis is false, the researcher is said to have rejected the null hypothesis. The probability value below which the null hypothesis is rejected is called the alpha level, or simply alpha. It is also called the significance level. When the null hypothesis is rejected, the effect is said to be statistically significant. For example, in the physician's reactions case study, the probability value is 0.0057. Therefore, the effect of obesity is statistically significant, and the null hypothesis that obesity makes no difference is rejected. It is very important to keep in mind that statistical significance means only that the null hypothesis of exactly no effect is rejected. It does not mean that the effect is important, which is what significant usually means. When an effect is significant, you can have confidence the effect is not exactly zero. Finding that an effect is significant does not tell you about how large or important the effect is. Do not confuse statistical significance with practical significance. A small effect can be highly significant if the sample size is large enough. Why does the word significant and the phrase statistically significant mean something so different from other uses of the word? Interestingly, this is because the meaning of significant in everyday language has changed. In the early 20th century, when the procedures for hypothesis testing were developed, something was significant if it signified something. Thus, finding that an effect is statistically significant signifies that the effect is real and not due to chance. Over the years, the meaning of significant changed, leading to the potential misinterpretation. There are two approaches, at least, to conducting significance tests. In one, favored by Ronald Fisher, a significance test is conducted and the probability value reflects the strength of the evidence against the null hypothesis. If the probability value is below 0.01, the data provide strong evidence that the null hypothesis is false. If the probability value is below 0.05 but larger than 0.01, then the null hypothesis is typically rejected, but not with as much confidence as it would be if the probability value were below 0.01. Probability values between 0.05 and 0.20 provide weak evidence against the null hypothesis, and by convention are not considered low enough to justify a confident conclusion that it is false. Higher probabilities indicate little to no evidence that the null hypothesis is false. The alternative approach, favored by the statisticians Neyman and Pearson, is to specify an alpha level before analyzing the data. If the data analysis results in a probability value below the alpha level, then the null hypothesis is rejected. If it is not, then the null hypothesis is not rejected. According to this perspective, if a result is significant, then it does not matter how significant it is. Moreover, if it is not significant, then it does not matter how close to being significant it is. Therefore, if the 0.05 level is being used, then probability values of 0.049 and 0.001 are treated identically. Similarly, probability values of 0.06 and 0.34 are treated identically. The former approach, preferred by Fisher, is more suitable for scientific research and will be adopted here except in the area of quality control. The latter is more suitable for applications in which a yes-no decision must be made. For example, if a statistical analysis were undertaken to determine whether a machine in a manufacturing plant were malfunctioning, the statistical analysis would be used to determine whether or not the machine should be shut down for repair. The plant manager would be less interested in assessing the weight of the evidence than in knowing what action should be taken. There is no need for an immediate decision in scientific research, where a researcher may conclude that there is some evidence against the null hypothesis, but that more research is needed before a definitive conclusion can be drawn. In many experimental designs, it is unlikely that two treatments lead to exactly identical outcomes. For example, could two diets lead to exactly the same weight loss, such as 4.1232 pounds? In cases such as this, the question becomes which treatment is better, rather than whether their effects are the same. If the difference between treatments is significant, then one can make a confident conclusion about which treatment is better.